Good morning. This is Professor Gardetto, and this is the third mini video for week number one. This is the last mini video that I'll be posting on on week one's module. This one has to deal with homework number three, also on Connect Math. Um, Before attempting homework number three problems, you should be at least at the 80% or higher mark for homeworks one and homeworks two. I'm on Connect Math right now, and I'm going to preview the assignment. So the assignment has 24 problems, and you're going to see a lot of these signs right here. These are absolute value signs. When you see the straight lines on either side of an expression. And basically, let's talk about the definition of absolute value. Okay. The easiest way to explain absolute value is it's the distance that something is away from zero on the number line. So here's a number line here. I'm going to be drawing a lot of number lines tonight. I think a sketch of a number line when you're doing these problems is going to help you tremendously on this homework assignment. And so the distance something is away from zero. So like say we take let's say we take here's zero right here. If I ask you what the absolute value of 3 is, right? So absolute values of 3, well 3 is right here. So 3, let me change colors. 3 is right here. Okay, so how far is 3 away from 0? Well, it's exactly 3 away from 0. So the absolute value of 3 is equal to 3. Let's say we had the absolute value of -3. These are absolute value signs here. So absolute value of -3. Well, -3 is on this side of 0. And I'm going to go over this again on our online Zoom session this morning, which you haven't been attending live because you work or you have other responsibilities at 9 a.m. You could also view those Zoom lectures online or on a conference Zoom. They should be recorded probably by noon every day, and you can view them at your leisure. So the absolute value of -3 is, well, how far is -3 away from 0? Well, let's see. It's 1, 2, 3. So it's also 3 away from 0. So if you notice, the absolute value can never be negative. Okay, when we're talking about distance, distance is always a positive number. Okay, so if we look at this problem here, it has a variable inside. So it says the absolute value of m equals 11. So that means that, well, m is going to equal 11 because the absolute value of 11 is equal to 11. Or m could equal, what else could m equal? M could also equal -11. So there's most of the time there's two answers to an absolute value equation because we have two sides. We have the positive side and we have the negative side. So when we write the solution set here, it's going to ask you probably to separate it with a comma. Yeah, here it is right here. So we're going to click this box here, and we're going to put 11 here, and we're going to put -11 here. Okay, and I can check my answer. Check my answer. Okay, just remember absolute value. Two different equations or two different answers. What's this say? Okay, they want it written in set notation. Okay, so let's take a look at what the alternate answer is. That's the same thing. I'll write the next one in set notation, but it's still giving me the green check mark. So these little dots here are just kind of like suggestions. As long as you get the green check mark, you'll be 100%. All right, so let's look at another one here. Let me clear this. Clear screen. Okay, and let's go to another one. Okay. All right. So this one here is basically the same thing, except for there's an added part here. It says absolute value b minus 9 equals 4. So before we solve absolute value equations, we want to isolate the absolute value sign on one side. So we want to get rid of this. We want to get rid of this minus 9, kind of like we're solving for b, except for b is in the absolute value sign. So when we do that, all we have to simply do is add 9 to both sides. We add 9 to that side and add 9 to this side. Then we have the absolute value of b equals 4 plus 9. 4 plus 9 is 13. So from there, we know that b's got to equal 13, but b can also equal negative 13. Remember, there's always two answers. There's always two answers to absolute values. So let's see. Yeah, let me do it using the set notation. So they want this, and then they want this. Okay, so I'm going to put this inside now. 13, and negative 13. Okay, and that should give me the correct answer. Okay. All right, let's look at some more here. Erase this. All right, so this one here, instead of having just a variable inside, there's an expression inside, but the absolute value sign is isolated. Okay, so let's see this right here. What's inside the absolute value sign? That's got to equal 9. That entire thing right there. That entire thing. 5y plus 2. That's got to equal 9 because the absolute value of 9 is equal to 9. So let me write that down. 5y plus 2 without the absolute value sign is got to equal 9. Okay. Or 5y plus 2 is got to equal negative 9, because we know the absolute value of negative 9 is also equal to 9. So all we have to do is solve these two equations. Notice I dropped the absolute value sign. When I write the two equations, I don't have to have the absolute value signs anymore, because I know this right here, the expression inside the absolute value sign has to equal one of two numbers, 9 or negative 9. Okay, so now I solve both of these. So 5y equals, subtract 2, so that's 7. And then y is equal to 7 over 5. And I'll just leave that as 7 over 5. I don't want to change to a decimal. I'll just leave it as a fraction. And then if I subtract 2 on both sides here, I get negative 11. And I get y is equal to negative 11 over 5. And I'm just going to leave it as negative 11 over 5. You can leave it as fractions as long as the fractions are reduced to lowest terms. And those fractions are reduced to lowest terms. So I'll put it here, and then, there's the fraction. So I'm going to click the fraction tool. And then I'm going to put 7 over 5. And then I'm going to click the fraction tool again, and I'm going to put negative 11 over 5. Okay, so that's how absolute value equations work. As long as your absolute value is isolated, you can write two separate equations, and you solve both those equations for the variable, and just separate those with a comma. Okay. So next we're going to talk about absolute value inequalities. Let's see. Okay, so here's a absolute value inequality. And when you have an inequality sign, and we're still talking about distance, right? We're still talking about distance from zero. Okay, so let me make a little example here that's non-mathematical. If I asked you name a city that's more than 7 miles away from, let's see, I'm in Rockland, so a city that's more than 7 miles away from Rockland, and we'll say you got to be on I-80. So if you're on Interstate 80 and you need to name a city more than 7 miles away from Rockland, you could say Reno. You could say, I'm just going up and down I-80. You can say Colfax. You could say Auburn. I think Auburn's more than 7 miles away from Rockland. You probably couldn't say Loomis. I think Loomis is closer than 7 miles. You couldn't say Roseville. Okay, you couldn't say Roseville. Roseville's close to Rockland. It's the next city down. You could say I think you could say Sacramento. I think Sacramento's more than 7 miles away. You definitely could say San Francisco. Okay, but there's a gap. There's a gap of cities that you couldn't say are more than 7 miles away from Rockland. Okay, so if you understand that, and I'm going to draw another number line here. Okay, I'm going to draw another number line. Okay, here's 0. Okay, so if we're more than 7 miles away, you can't be exactly 7 miles away. So you can't be in between here. You have to be, let me use the, okay, those are open circles. Those are not colored in. Those are open. So you can't be exactly 7 miles away. If you're more than 7 miles away from Rockland, or if you're more than 7 away from 0, you have to be over here, and you can be all the way down here, or you have to be over here, or it could be all the way down there. Okay, but there is a gap. There's a gap right here that's left unshaded. Okay, this is the gap. Okay, so the way to write your solution set, because this is basically the answer right here. That's the answer. The way to write your solution set is a little bit different than, well, we can't. Let me put this over here. Okay, so we notice when we click the box, we have all these different icons here. So notice the one right here, the one that has this big U, this U right here, that means that's the gap. Okay, the U is the gap. Think about it as like the Grand Canyon. Okay, the Grand Canyon. If you've been on seen the Grand Canyon, it's a very deep hole. So that's the gap right here. Okay, and this sign right here is the gap sign. So we have to click this because there's a gap in our solution. And then we have to click the left-hand side first. And the left-hand side is this part of the gap, or this part before we get to the gap. We got to go left to right. So this arrow goes all the way down to negative infinity. So there's a negative infinity sign right here. But it stops at -7, and it does not include -7. So if it doesn't include it, we use these tools. We use the rounded parentheses. So I'm going to click this, and then I'm going to put in negative infinity, and then I'm going to put in -7. Okay, and then I'm going to leave the gap because that's the gap right there. And then I'm going to start at 7. So I'm going to go 7. And then it goes to positive infinity. Okay. So it's got to look like that. Negative infinity to -7, gap, 7 to positive infinity. If your absolute value sign is greater than 7. Okay. I'm going to check my answer. And then once you have part 1 done, part 2 will be pretty easy because part 2 is just asking you to reproduce this this graph here. So I'm just going to reproduce it, and using the tools that they give you these tools here. So I'm going to go to, let's see, I'm going to use this one. I'm going to put this over here at -7. I'm going to use this one. I'm going to put this one here at 7. And then I'm going to use the line tool to highlight this one on the left. I'm not going to put anything in the gap because the gap should be left unshaded. And then just make sure you click and then check answer. Okay, and then we get the 2 green check marks. Okay, and the graph will be just what you're going to be drawing the graph on your own anyways, and just you're going to replay it over there. Okay. All right, let's try another one here. Okay, that's absolute value. Okay, let's try an absolute value greater than. Actually, that was 9 was absolute value greater than, right? Yeah, okay, let's try an absolute value less than. That's greater than. Okay, here's one less than or equal to. Okay, so the absolute value sign now is less than or equal to. So let's, again, let me give you the analogy of a distance away from the city of Rockland, right? If I said you have to walk, you have to be within 2 miles of the city of Rockland, right? Well, you couldn't be in Auburn, you couldn't be in Colfax, you couldn't be in San Francisco. Okay, if you're within 2 miles of the city of Rockland, you could be in Lincoln, you could be in Roseville, you could be in you could be maybe in Citrus. No, you probably aren't going to be able to be in Citrus Heights. You city of Rockland, you have to be like really close to the city of Rockland if you're within 2 miles. Okay, so this is what happens if it's less than. Let me again draw a graph for you. Okay. Okay, that's supposed to be a straight line, but so here's 0. Right. So if you're less than 2, if you're less than 2 miles away from 0, if you're less than 2 away from 0, well, here's 1 and here's 2. And this is less than or equal to, right? So you could be exactly 2. You could be exactly right there. That's exactly 2, But less than 2 means you could be anywhere here. That's less than 2 away from 0. And all the way here. You just can't be over here. You can't be in this area over here, and you can't be in this area over here if you're less than 2. So there is no gap. There is no gap when we have a less than or equal to. So, I mean, this is your answer right here, between -2 and +2. So when we write your answer, the solution set, it's going to have these brackets, because the brackets are for the ones that have exactly that number. So when you have less than or equal to or greater than or equal to, you're going to be using the brackets. So I'm going to click the bracket, and then I'm going to just put in -2 and +2. And check the answer. Okay, and then they just want you to write the solution, but you're already going to have the solution sketched out. So it's -2 to +2. So it's the brackets here. So we go to -2 using the bracket, right-hand bracket. You go to +2, and then you click the line tool. This basically shades the area in between. We don't want to put there. We don't want to put there. We want to put it right in the middle. Just make sure you click it before you check your answer. So it should be yellow. When you go to check your answer here, just make sure it's yellow. Check my answer. And when you check it, it turns blue or purple, that color. Okay. So I tried to give you those two examples back to back. The ones that are greater than have the gap. The ones that are less than do not have the gap. Okay, so let's try one more, and then I will let you guys go. And maybe if you need more examples, tune in to the live Zoom lecture at 9 o'clock this morning, or view it at a later time. Okay, let's clear screen. All right, so this one here is kind of turned around. It's the absolute value is on the right-hand side instead of the left-hand side. So, and I talked a little bit about this on yesterday's mini videos. I want to turn these around. I want to put the absolute value on the left-hand side. It works a lot better. So I'm going to rewrite this absolute value P-3. Now, when I turn it around, when I flip it, when I put this over here and I put the 4 over here, the inequality sign's got to flip too. Because see, it's pointing towards the 4. So it's got to be pointing towards the 4. So it's got to be a greater than or equal to sign. And the 4 has got to be here. Okay, so now, if you have something inside your absolute value sign that is not just a letter, if there's an expression, we're going to have to solve this. Okay, but it's a greater than or equal to. It's greater than or equal to. So we're definitely going to have a gap. Okay, we're going to have a gap. Okay, we're going to have a gap because this is similar to the Grand Canyon problem that we had before. Okay, so I'm going to draw the number line. Okay, but and here's 0. So this P-3 is got to be greater than or equal to 4 units away from 0. So 4 units away from 0. 4 units away from 0. So it's going to be greater than or equal to 4 units away from 0. So greater than or equal to is this way or this way. Okay, so there's going to be a gap in between. Now, P-3, I'm going to write down P-3, P-3, and this number here is -4. So all these values here in this red line here are less than or equal to -4. So I'm writing out an inequality without the absolute value sign. P minus 3 is less than or equal to negative 4. And I know that because it's greater than or equal to 4 units away from 0. So I'm doing the left-hand side first. Okay. Then we have a gap. We have a gap. Okay. The gap is between here and here. This is also 4. And now I'm going to write down the inequality sign for this part, P minus 3. And all these values here in red are greater than or equal to 4. So I'll let you guys absorb that for a second. I wrote down what was inside the absolute value sign, less than or equal to negative 4, because that's on this side. And then I wrote down what's inside the absolute value sign, and it's greater than or equal to 4, and that's what it's on this side, on the right-hand side. And now I simply have to solve this for P. So if I add 3 to both sides, this is going to be P is less than or equal to, if I add 3, this is negative 1. And if I add 3 on both sides here, this is going to be P is greater than or equal to positive 7. Okay. So my solution set's going to be less than or equal to negative 1. So let me put that in orange here. Okay, so here's negative 1. So less than or equal to negative 1 is all these values here. So all those values there. This is negative 1. And greater than or equal to 7. So 7 is right here. And it's going to be greater than 7. So all those values there. So including these arrows, those are shaded, and these are shaded this way. Okay, so here's my gap. My gap is from negative 1 to positive 7 is my gap. This is my gap right here. That's the gap. Okay, so now what we do is we put that answer here as a solution set. So remember, to put the gap, you have to put the gap right here. You have to click that. And then we want to see what we have. We have all the way to negative 1, and we do want to include negative 1. So we're going to use these signs. I'll do the left one first. We're going to use the rounded parentheses for the negative infinity, but they're going to use the brackets because we want it to include negative 1. And there's the gap. And then I want to use, let's see, I have to be careful. I'm going to start with 7 because the gap is going to go from negative 1 to 7. And then 7 is included because it's greater than or equal to 7. So I'm going to use the bracket and then the rounded parentheses. So I'm going to use the bracket first. So that's 7. And then the rounded parentheses for the infinity. Infinity signs always have the rounded parentheses because you can't really get there. So let's just make sure that's accurate. Negative infinity to negative 1 and 7 to positive infinity. Check the answer. Okay, and then part 2 just asks you to graph. Okay, so basically the orange area here that I have is going to be reproduced down here. So I'm going to use the right-hand bracket first, and that was at negative 1. The left-hand bracket, that's at 7. And I'm going to put the tools here and tools here. And you should actually have the graph already done, just sketched out. So part 2 shouldn't be a problem. Check my answer. Okay. If you need more instruction, view the live lecture today. It's going to be at 9 o'clock. Today is Wednesday, June 16th. All right. I will talk to you guys later. Bye.